So in this section, we will be learning about finding the domain and the range. And we're going to start with the domain. So for these examples, we'll find the domain of the function. Recall that the domain is going to be our possible input values. In this case, it's going to be our x values. So there's a few things that we need to look out for. There are two major things for now that our domain cannot include. And those are the things that I want you to look for. So the first thing, it can include x values that give a 0 denominator. The second thing is it can't include x values that give a negative under a square root. So we only want to look at real numbers, so we can't have negatives under square roots, and we also can't have a 0 denominator. So for number 1, you can see that there is a potential to get a 0 denominator. And what you can do is you can look at this denominator, x minus 8, and you might be able to figure out in your head what value of x would give you a 0 denominator. The other way you can do it is you can actually write an equation out. So we do not want x minus 8 equals 0. If you want, you can even write it as x minus 8 is not equal to 0, because we're not allowed to have that. That would give you that x is not equal 8. So then, putting it all together, our domain is going to be all real numbers except for 8. So then, for number 2, we see our second red flag, which is a square root. So we want the stuff that's under the square root to be greater than 0, or greater than or equal to 0. We want this stuff, the 5x minus 20, to be non-negative. So what I'm going to do is I'm going to write an inequality as 5x minus 20 is greater than or equal to 0. So then I can solve this out for x. And when I do that, I get x is greater than or equal to 4. You can actually write your domain as x is greater than or equal to 4, but a better way to write it would be to write all real numbers where x is greater than or equal to 4. That would be our perfect domain. So now number 3 is interesting because you'll see that there's nothing in there that is really that bad. There are no square roots, there are no denominators. In the future, we're going to actually have logarithms, but we're not going to worry about that right now. So this one doesn't have anything that we can really object to. So our domain is actually going to be all real numbers. You can also say all real values of x. So finding the range is a little bit harder. We're not going to go into a lot of detail about it, but we're going to go into how to find the range and also the domain based on looking at a graph. So we'll do some examples of that right now. So for these ones, we're going to estimate the domain and the range. And for the first one, they actually show us endpoints, which are going to be what's going to help us to figure out where the domain and the range are. So let's start with the domain. So the domain is going to be our possible x values. And it's going to go from the dot on the left to the dot on the right. And so we're going to start with the point on the left. That one is at -4. The one on the right is at +1. So there's two ways to write this one. I'm going to show you the first way, which is writing it as an inequality. It would be written as -4 is less than or equal to x is less than 1. It's important to notice that at the 1 we have an open circle, therefore we keep it as less than, not less than or equal to. Unfortunately, I'm going to make this a little bit harder than you on you in this case, because I'm going to ask you to write it in what we call interval notation. So we're going to use the same numbers, but this time we're going to write it as -4, 1. The -4 is going to have a square bracket to show that it's less than or equal to, and the 1 is going to have a round parenthesis. So that shows that we include the -4, we don't include the 1. So this is actually the answer that I would prefer you to put on a test or a quiz. So now for our range, it's a similar idea, except that we're going to look at our y values. So the lowest y value that we have is 0. And then the highest y value that we have is going to be at 5. So we're going to write this as 0, 5. 0 is going to be a closed bracket, a square bracket, because we include 0. 5 is going to be a round bracket, and so that's how we write our answer for that. So now number 5 is interesting because we have arrows at the end that show us that we go on forever and ever. So let's start with our domain. So a lot of people want to look at this and say that our domain starts at -4. Unfortunately, even though it looks like it starts at -4, it actually would go further because we have that arrow there that's showing us it goes on forever and ever and ever. So our domain is going to be all real numbers. So just to make this more interesting for us, I'm actually going to show you how to write that domain as an interval. So we say that our domain goes from -infinity to +infinity. By the way, notice that my brackets are both round. Keep them that way for infinities. Our range, you might guess, is also all real numbers. We can have anything for our y values. So it's also going to go from -infinity to +infinity.